Hi everyone, this lab 6 is about measuring temperature using thermocouples. So the thermocouple is nothing but two different metal wires connected to each other at a certain node, and if there's a temperature difference in different locations, then this temperature difference is going to create some voltage, and that is proportional to some constant, which is called as a Seebeck constant. And in this lab, basically you're going to measure temperatures in the air, ice water, and of your body. And by doing that, you are required to find the time constant of the thermocouple and the Seebeck coefficient. So the way we find the time constant is that we assume this thermocouple is a first order system. So it provides a similar behavior to the RC circuit. So for example, if you had this thermocouple, it just basically looks like, it's a wire, and you're going to have some kind of amplifier and some processing tool, and that is being connected to the PC through a USB. And this is the node here. So basically you're gonna put this in the air to measure the temperature of the air, and you're gonna grab this part using your fingers to measure your body temperature. So this part is when your thermocouple is in the air, and this part is when you're grabbing that. Again, if you release it, the temperature is going to drop down, and then it's going to rise up once you grab this part again. So you need to repeat this for about 10 times to obtain the mean and standard deviation of the time constant. So you may have some value at your room temperature, right? Say it's like 70 Fahrenheit or something like that. But from there, as you grab the thermocouple tip here, then you are immediately applying a step input of your body temperature, and the measurement gradually grows up, and then it gets saturated like this. And once you feel like it got saturated, you just release that. Then in the air, the temperature is going to drop down and be saturated again. And once it's saturated, you grab that again, its temperature should rise up, and then it gets saturated, and then you just release it. It goes down like that. So, and from here, the time constant is obtained by time it takes to rise up 63% out of 100%. So this is the time tau, the time constant tau. Okay, so make sure that you don't measure this from 0. So it is not the time it takes to rise up 100%, 63% out of 100. So it's not the time from here to there. This is not the tau. You should reference to your initial value. So this is going to be your initial value. So you have to count this difference as 100, and out of that you may want to find when it reaches up to about 63%. So the time from here to there is going to be your tau. And very interestingly, these values are going to be pretty similar throughout your measurement. So when you repeat this for 10 times, and once you process the data, you're going to see that the value is pretty consistent, and the standard deviation is pretty low. So that's how you measure the time constant of a system, for example, like this thermocouple, by just looking at its response. And the next step you're going to do is to find the Seebeck constant. So this constant alpha is a Seebeck constant. So your output voltage is proportional to the difference of the temperature. And this Seebeck constant is a very small value. It's in the order of 10 to the negative 6. So if this value were pretty large, again, you're going to feel a great amount of voltage depending on the temperature difference, right? But we never experience any spark or anything while you just connect two different metals like these. So this alpha is, again, the Seebeck constant, very, very small value. And we would like to find that, actually. And all you need to do is you have to measure the temperature and the voltage when you are in the ice water. And when you put that out in the air, measure the temperature and also the voltage, and also you measure your body temperature. So I'd recommend measuring your body temperature first, and then room temperature and the ice water later. Don't measure the ice water first, because once you stick that thermocouple into the water and you try to measure the room temperature and body temperature, this thermocouple is going to be wet, and that is going to affect your measurement. So you may want to measure those dry and then eventually put this into the ice water. So all you need to do is you need to just fill this table, find 6 values, and then you are going to plot the voltage with respect to the temperatures. That way you may have like 3 values. For example, this is for the iced water. This may correspond to the room temperature, and this may be your body temperature. And from there you may want to find the fitted curve and find the slope of it. And that slope is, again, the Seebeck constant. It's in the order of 10 to the negative 6, 10 to the negative 5, or 10 to the negative 7. It's going to be something close to that value, okay? Again, Lab 6 is for measuring the temperature using thermocouple, and it's a very simple one. All you need to do is just repeat this measurement for 10 times and fill in this table and just draw this curve to find the Seebeck constant. And while this is a very simple lab experiment, this part, the first part, takes quite a long time, because the time it takes to reach to steady state was, I don't remember exactly, but it was not like 1 or 2 seconds. It was like a minute or something like that. So when you repeat this part, it took a while. So you may want to focus really hard to not to make any mistake. Just finish in one shot. And yep, I'll see you guys in the lab